Today's video lesson is Chapter 2, Lesson 2C. We're going to compute with scientific notation. Really what that means is we're going to do math. We're going to do math problems with numbers that are in scientific notation. If the question was 4.2 times 10 to the third times 1.6 times 10 to the fourth, we get to do this in two stages. Think of it as multiplying the decimal numbers, and then when we multiply these, remember that multiplying is really just adding. So we're going to multiply the blue stuff, multiply the 4.2 times 1.6, and the pink stuff, we're going to add the exponents. Add the exponents, and we're still going to write times, and we're still going to write the 10. All right, so I've multiplied the digits. Remember, these just happen to line up, but when you're multiplying, you don't need to line them up. We're just going to pretend it's 42 and 16. And then you do the counting, 1, 2, 1, 2. That's where you know where the dot goes. 6.72 times 10. And we said that we were going to add these numbers together. 3 plus 4 is 7. 10 to the 7th. So this math problem ended up being this answer. Multiply the blue stuff, add the exponent of the purple stuff. All right, let's look at this question. What's different about this question is I made one of the exponents negative, but that's okay. That's not going to change anything. I'm going to multiply these guys, and I'm going to add these guys. When I multiply 84 and 61, oh, I thought I was finished. I get something really great. Here I go. 5124 are my digits. Remember, I do that counting trick. 1, 2, 1, 2. Put the dot there. 51.24 times 10 to the, well, I'm not quite sure, but I know I'm going to do negative 3 plus 8. And one negative means I really subtract, and I get a 5. And we're not done. We are not done. Last time we were done. We were done. We multiplied, we put our dot, we added the pink numbers, we got a 7, we were done. What makes this not be done? What looks funky about this? Well, what looks funky is that we cannot have two, we have to fix this guy. We can't have two numbers before the decimal place. Okay, so really what this means is 5, 1, 2, 4. I'm going to go 5 hops to the right. 1, 2, 3, 4, 5. Now if I go backwards and I fix it to 5.124, then I would go 1, 2, 3. Oh, I want to do this differently. I want to go 1, 2, 3, 4, 5, 6. Okay, so what just happened? What just happened? Let's talk about this again. So, we multiplied the blue stuff. 51.24. I wrote 51.24. I added my exponents. I added this, really subtract, think bigger, I got a 5. I realized that I can't have two numbers in front of the dot. So I have to fix it. I have to put the dot here. 5.124. But since I hopped it backwards one, I'm going to have to add 1 to this. So let's write a rule down in our notes. Anytime, so this is all about fixing. When you fix and you have to make it smaller, and what I mean by that is we were at 51.24. We had to make it to 5.124. Anytime I'm making it a smaller number, I'm going to have to adjust that by making the exponent bigger. If I make the numbers smaller, I have to make the exponent bigger. So I went from 51 down to 5. That's one place smaller, so I'm going to go one place bigger so that because I want to keep the same number. Like this is this makes this and this makes this, but this is how to correctly do scientific notation. All right, you try each of these. I made the numbers super easy, 2 times 3. So when you do the blue stuff, it's gonna be super easy and super fast. And when you do the pink stuff, remember you have a negative. When you do the pink stuff, you don't have any negatives. And hint, hint, you're gonna have to fix this guy. He's gonna be too big. All right, push pause, work it out, see what you get. All right, the first one, 2 times 3 is 6. Over here, I worked out the 9. Oh, I did it wrong. Shoot, okay, hold on, just kidding. I did it wrong. 9 plus -2, which just scribbles. So 9 minus 2 is 7. Oh, see, I did it wrong. All right, so 6 times 10 to the 7th. I have a single number. I don't have to fix anybody. I'm happy. This one, I have 32. 8 times 4 is 32. Times 10 to the 7th. 3 plus 4 is 7. I don't want 2 digits. I can only have 1 digit. So if I make it 1 place smaller, I go 1 place bigger with my exponent. All right, let's do dividing. Dividing is similar. We're gonna divide the blue stuff. 12 divided by 3 is 4. But the exponents, this time we're going to subtract. Remember, subtracting goes with division. When you divide, you subtract the teeny guys. So I'm going to subtract 4 minus 2. So there's my final answer. 4 times 10 to the 2nd power, and 4 is fine, it's a single digit. I tried to do an easy one here for you the first time. You try this one. 24 times 10 to the -6 divided by 6 times 10 squared. Don't forget you're going to subtract these. So when you, I'm not gonna give you any hints, sorry. Push pause, you try it, and then I'll give you hints in a second. 4 times 10 to the -8th. So remember we're subtracting, so I wrote -6, then I wrote a minus sign, and then I wrote 2. If this had been negative, we would write -6 minus negative something. And I really feel like if you try to do this in your head, you're going to make a mistake. If you see it on paper, if you take the extra time to write it out, you're more likely to get the correct answer right there. Did we have to fix? No, we did not. All right, let's work this one out. This one has decimals. Most of the time, they're not going to be whole numbers. Most of the time, they'll be decimals. So I need to divide my 9.72 divided by 3.6. Remember that when you divide by decimals, you hop over 1 place, and it really becomes 36, and it really becomes 97.2. All right, so when I do the division, the scratch work, I end up with 2.7. So that means that this, oops, I meant to do that with my little thing. That means this part of it is 2.7. I'm happy because I don't have to fix anybody. 2.7 times 10 to the, I think this is okay to do in your head, 7 minus 3. If they're negatives, that's when I think that you should write it out. All right, let's try this one. So we're going to divide this, we're going to subtract this. Take my word for it that we end up with 0.69 when we do the division. I don't want to bog down and do all this, but just trust me that it's going to be 0.69. And then subtract this, and I get 10 to the 3rd. I don't like this because it's not in scientific notation. It's too small. I need to make it 1 place bigger. Since I'm making that number bigger, I have to make that number smaller. Okay, so let's write that down. If you fix and you make the decimal bigger, make the exponent smaller. Okay. All right, let's talk a little bit about our second lesson that we're going to do tomorrow, and that's square roots. So you should memorize this list of perfect squares. I don't think it's going to take you long to memorize this list, But you need to have this list memorized because most of these square roots are just the opposite of this list. All right, so 1 squared means 1 times 1, 2 squared, 2 times 2, 3 squared, 3 times 3, and so on. And there's our entire list. So remember, it's just the number times itself, but you should memorize this list up to 15. So when we do square roots, all we're doing is the backwards. A square root sign looks like this. Square root. It looks kind of like a division sign, like the house, but it has this extra V, this extra piece. So if I said, what's the square root of 9? The answer is 3. So they're going to take the numbers back here, they're going to put them inside this little house, and the number that's right here, the base, not the whole thing, but the base, 3, because 3 times 3 is what would equal 9. Square root of 16 is 4. Square root of 100 is 10. Oh, I wrote 100, 10. Square root of 169, 13. Square root of 25, that's 5. Okay, then if they were to put a negative on the outside of the square root sign, you would put a negative in your answer. So if there was a negative out here, it becomes a negative right here. Negative out here becomes a negative right here. If you were to see something that had a negative on the inside, which they won't do, oh, they did do it. No way. So if they do, yeah, they're going to, then you're going to say impossible, imaginary, can't do it. The book uses words like no real answer, no real root. You can just say anything. No answer, not possible, can't do it, no number. There's nothing that makes if you had 2 of the same, because if you had 3 times 3, that's going to equal positive 9. And if you had negative 3 and a negative 3, that's going to still equal positive 9. There's no way for these two to match and to be negative. And then what they could do is they could start making fractions out of it. What is the square root of 4/9? Again, they're still going to keep using these basic numbers. So that's why this list is super helpful to have memorized. If they do the square root of 4/9, you're going to break it into 2 parts. Square root of 4, square root of 9. Answer on top, answer on bottom, boom, you're done. Let's see, what else could they do? They could do a decimal. So if I had 0.3 times 0.3, that would be 0.09. So they could ask you the square root of 0.09, and you would say 0.3 again. So they could do decimals. What else could they do? Oh, they could do this. They could say plus or minus the square root of 196. And all you're going to do is go plus or minus 14. If they have a little plus or minus, you write a plus or minus. Let's see what else. They could do like an equation where they say x squared is equal to 16. Square root both sides, and you write x is 4. But I need to see this yellow stuff. Square rooting gets rid of the tiny 2. So that's why it's just an x. It's not a tiny 2 with an x. It's just an x. So if they said the square root of m, oh, shoot, they won't say that. They will say m squared is equal to 81. You would go square root sign, m equals 9. Yeah, so that's what they're going to do. All right, let's do Google Classroom questions. Your Google Classroom questions. All right, I'm going to give you some easy ones, some with whole numbers. So remember, this is multiply, that means you add. This is division, that means you subtract. And finally, what is the square root of 36?